Concept 2, solving systems of equations by substituting and distributing. Alright, so when we have two equations, so we have a system of equations where we have one variable, and it can be y or it can be x, but usually it's y, and we have one variable that's already isolated in both equations, it's pretty easy to substitute and then solve that equation. Alright, but sometimes we don't. Sometimes we'll maybe have one equation where we've already got a variable isolated, and then we have to substitute that into another equation where that variable is not isolated. Right? It's got something that's multiplying by here, it's got a negative or a subtraction here, it's not alone on one side of the equal sign. Okay, so in this case, we're still going to substitute, but now we're going to be using the excuse me, the distributive property to solve our equation. Okay, so we're still going to say, all right, x plus 1, that is still equal to y, so this y is still equal to x plus 1. And I'm going to rewrite it down here, but I've got this 2. Okay, so I've got to put what I'm substituting in parentheses. So it's 2 times x plus 1, close parentheses, and then write out the rest of my equation. 4x equals negative 4. Okay, and now once we've done that, this is actually back to something that should be familiar. Okay, we've used distributive property, we've multiplied this out. Alright, you've done that before and then combined like terms. So you're comfortable with this. You just need to make sure that when you are substituting, you don't lose whatever you're multiplying y by or dividing y by, whatever the case may be. Okay, so I've got 2 times x plus 1, so I'm going to distribute that 2 out into both of my terms. So 2 times x is 2x plus 2 times 1 is 2 minus 4x equals negative 4. Okay, so I'm done with the distributive property, done with step 2. Now I'm going to move all my variables and constants. Well, in this case, it's actually a little easier because my variables are all on the same side. So I just need to move this positive 2 away by subtracting 2 from both sides. That cancels. I'm left with 2x minus 4x equals negative 4 minus 2. 2x minus 4x, now I'm combining my like terms. That's going to be a negative 2x is equal to negative 4 minus 2, or negative 6. Okay, and now I'm going to solve for my variable. Divide by negative 2. Divide by negative 2, and I get x is equal to 3. Okay, and that might seem like a pretty long process, and there are quite a few steps to get to it. We've kind of been adding more and more steps as we go, but we still have one more thing we've got to do. Okay, I figured out my x value. Now I've got to solve for my y. I've got to solve for the other variable, and the way I'm going to do that is to plug it into my original equation, and I'm going to plug it into the one where I already have my y isolated, right? You should always have one where you have your other variable isolated, because that's how you substitute into this equation, right? So I'm going to bring this down, and I'm going to have y equals x plus 3, but I'm going to or x plus 1, but I'm going to substitute x, so 3 plus 1, or y equals 4. Okay, and so this is the solution to my system, and it can be written like this: x equals 3 and y equals 4, or I could write it as an ordered pair, 3, 4, because remember, the solution to a system is also that point on the graph where those lines cross. Okay, all right, let's do another one. And this one might be a little trickier because we've got fractions in there, but we should be able to make it work. Okay, So I've already got y isolated here. So this is what I'm going to be substituting. Okay, I'm going to bring my 2 down, open my parentheses. So this comes in for y, 4x minus 3, okay, plus 1/2 x equals 11. All right, now I'm going to distribute out. 2 times 4x is 8x. Oops, it's not a very good x. 8x minus 3, so 2 times negative 3 is going to be a negative 6, plus 1/2 x equals 11. All right. Now I've got this fraction. I don't really want to deal with it, but what I'm actually going to do is hold off on that just for a second. So I'm going to move this 6 over. Okay, plus 6. Oh, that's the bell. I better hurry. Plus 6. So I have those canceled. I have 8x plus 1/2 x equals 11 plus 6 or 17. I'm going to multiply everything by 2 to get rid of this fraction times 2. Okay, so I have 16x plus these 2 cancel plus 1x equals 17 times 2 or 34. Oh, and now it looks like it's going to be nice to me. 16x plus 1x is 17x. And I know from what I just did that 17x is half of 34. So when I divide by 17, I know x is going to equal 2. Okay, pull that back up to my original equation. I have y equals 4 times 2 minus 3. Y equals 8 minus 3. Or y equals 5. And there we have it.